the structure of ionic compounds. What is the structure of something? When we talk about chemical bond, we know that chemical bonds describe the electron situation between the bonded atoms. But what is the structure of a compound? The structure of a compound describes the positioning of the atoms inside the compounds in three-dimensional space. Basically, it tells you the positioning of each atom or ions in the compound. So finally, what shape do they make? Okay, that's the structure, the geometry of the compound. That is called the structure of a compound. Here we talk about the structure of ionic compounds, and here is the general description for solid ionic compounds. It consists of positive and negative ions. These ions are arranged in such a way that each ion is surrounded by a nearest neighbors of the opposite charge. Oh, this one tells you each positive ion is actually surrounded by a few negatively charged ions. And each negative ion is surrounded by a few positively charged ions. It's called neighbors, not neighbor. Okay? And all these ions, each ion is bounded by attractions to all the neighbors. Okay. I'm not sure about you, but to me, a description like this, to me, is kind of hard to visualize. What is this talking about? How will that structure look like? So let's use one example, of course, sodium chloride, to talk about this. Let's use sodium chloride as an example to talk about the structure of sodium chloride. On the right of this picture, it shows you a few sodium chloride crystals. Actually, all of us can make these crystals. When you go home, dissolve some table salt in water, leave the water solution somewhere, don't disturb it. A few days later, you will see cubic crystals appear. They will look just like this. How come do the crystals show up as cubics? That is because the unique positions of the sodium ion and chloride ions are taken inside the compound. Here is a three-dimensional drawing, amplified, showing all the atoms inside. Okay, this structure grows three-dimensionally, X, Y, Z, it grows. Here is a two-dimensional cut. Okay, the green ones represent chloride ions. The gray or silver ones represent sodium ions. As you can see in this two-dimensional cut, each chloride ion is surrounded by 4 sodium ions, and each sodium ion is also surrounded by 4 chloride ions. However, keep in mind, this two-dimensional cut structure grows forward and backwards. So if you look at the sodium ions around the chloride, let's use this chloride as an example. As a matter of fact, I hope you can visualize that. Right in front of this chloride ion, there is a sodium ion, and right behind the chloride ion, there's another sodium ion, so that it grows three-dimensionally. So each chloride ion in space is actually surrounded by 6 sodium ions. Same thing is true for the sodium ion. Each sodium ion is surrounded by 6 chloride ions in three-dimensional space. All ionic compounds have three-dimensional lattice structures. They may arrange the atom a little bit differently. They may arrange the ions a little bit differently from what is shown here for sodium chloride. However, they will all have this kind of three-dimensional lattice structures. In this specific case, for sodium chloride, again, there are 6 chloride ions around each sodium ion, and there are 6 sodium ions around each chloride ion. Oh, now we realize that even though we keep using NaCl to represent sodium chloride, now suddenly, after looking at the structure of sodium chloride, we realized that there isn't an isolated NaCl unit in which there's only one sodium and one chloride in it. There isn't such unit in the compound. As a matter of fact, when a few atoms combine together and form another individual unit that acts as one particle, that kind of unit is called a molecule. Molecules will be the topic for next chapter, but here I mention it because I want to remind everything looking at the three-dimensional structure, we all should know that any compounds do not have molecules. So what is the formula of NaCl then? What do we call it if this one doesn't actually exist in the compound? Why do we write it? Well, the formula of any compounds represents the repeating unit, the simplest, smallest whole number repeating unit inside the compound. Of course, you use the simplest ratio. Here we go. In the case of sodium chloride is the simplest repeating unit in that three-dimensional lattice structure.